Drilling holes in outlet boxes is not explicitly prohibited by NEC 2020 Section 110.3. However, the National Electrical Code, or NEC, mandates that all boxes be securely fastened and adequately supported. The chosen fastening method must also be suitable for the available space in the box's intended application. When considering drilling holes in an outlet box to create alternative mounting locations, the primary concern is maintaining the box's structural integrity and ensuring it remains securely mounted after the modification. It is essential to consider several factors to ensure compliance and safety. Firstly, before drilling any holes, carefully assess the box's material. Outlet boxes are typically made of metal, such as steel or aluminum, or non-metallic materials, like plastic. The drilling technique and tool selection should be appropriate for the specific material to avoid damaging the box. Secondly, determine the appropriate size and location for the new mounting holes. Consider the size and weight of the equipment or device that will be supported by the box. Ensure that the new holes are positioned to provide adequate support and prevent the box from becoming unstable. Thirdly, when drilling the holes, use appropriate tools and techniques. A step drill bit or a unibit is generally recommended for drilling clean, round holes in metal or plastic outlet boxes. These bits create smooth edges and minimize the risk of burrs or sharp edges that could damage conductors or pose a safety hazard. Fourthly, after drilling the holes, inspect them carefully for any burrs or sharp edges. Remove any imperfections with a deburring tool or file to ensure a smooth surface. This will protect conductors from abrasion and prevent potential electrical hazards. Fifthly, select appropriate fasteners to secure the outlet box to the mounting surface. Use screws, bolts, or other fasteners that are suitable for the box material and the mounting surface. Ensure that the fasteners are long enough to provide a secure hold, but not so long that they protrude excessively and create a hazard. Sixthly, when fastening the outlet box, tighten the fasteners securely but avoid over-tightening. Over-tightening can damage the box or the mounting surface, compromising the integrity of the connection. Seventhly, after mounting the outlet box, inspect it carefully to ensure that it is securely fastened and adequately supported. Check for any signs of movement or instability. If necessary, add additional support or reinforcement to ensure that the box remains firmly in place. It's also important to consider the specific requirements of the NEC and any local electrical codes that may apply to your installation. These codes may provide additional guidance on the proper methods for mounting outlet boxes and ensuring electrical safety. When in doubt, consult with a qualified electrician to ensure that your installation complies with all applicable codes and standards. Additionally, it is important to be aware of the potential consequences of drilling holes in outlet boxes that are not properly supported. If the box becomes loose or unstable, it could create a safety hazard, such as an electrical shock or fire. Therefore, it is essential to take all necessary precautions to ensure that the box remains securely mounted after the modification. Finally, consider using alternative mounting methods that do not require drilling holes in the outlet box. For example, some outlet boxes have built-in mounting brackets or flanges that can be used to secure the box to the mounting surface. Alternatively, you can use adhesive mounting pads or straps to attach the box to the surface without drilling any holes. These alternative mounting methods can be a convenient and effective way to avoid the potential risks associated with drilling holes in outlet boxes. Remember that the primary goal is to ensure that the outlet box is securely fastened and adequately supported, regardless of the mounting method used. By following these guidelines, you can safely and effectively drill holes in outlet boxes to provide alternative mounting locations while maintaining compliance with the NEC and ensuring electrical safety. Let's delve deeper into some of the crucial aspects when drilling outlet boxes for mounting, focusing on specific NEC sections and best practices. Firstly, NEC Section 314.23 covers the requirements for supporting boxes and conduit bodies. This section emphasizes the importance of independent support for boxes, meaning the box should be supported directly to the building structure or a suitable mounting surface, rather than relying solely on the raceway or conductors for support. Secondly, when drilling holes, it's vital to avoid compromising the internal volume of the box. NEC section 314.16 dictates the minimum volume requirements for outlet boxes based on the number and size of conductors, devices, and fittings contained within the box. Drilling too many or excessively large holes can reduce the available volume, potentially leading to overcrowding and difficulty in making safe and compliant connections. Thirdly, consider the environment where the outlet box is installed. If the box is located in a damp or wet location, it's crucial to maintain its weatherproof integrity. Drilling holes can create pathways for moisture to enter the box, leading to corrosion and electrical hazards. In such cases, use appropriate sealing methods such as waterproof connectors or sealant to protect the box from moisture intrusion. Fourthly, pay attention to the type of wiring method used in conjunction with the outlet box. If using non-metallic sheath cable or NM cable, ensure that the drilled holes are smooth and free of sharp edges to prevent damage to the cable insulation. Use cable clamps or bushings to protect the cable as it enters the box. Fifthly, when drilling holes in metal outlet boxes, be aware of the potential for creating electrical shorts. If the drill bit comes into contact with energized conductors inside the box, it can create a dangerous short circuit. Always de-energize the circuit before drilling any holes in metal boxes. Sixthly, consider the type of equipment or device that will be mounted to the outlet box. If the equipment is heavy or subject to vibration, it's essential to use robust mounting hardware and techniques to ensure a secure and reliable connection. Use appropriate size screws, bolts, or other fasteners that are designed to withstand the weight and vibration of the equipment. Seventhly, if you're unsure about the proper methods for drilling and mounting outlet boxes, it's always best to consult with a qualified electrician. An electrician can assess the specific situation, identify any potential hazards, and recommend the most appropriate techniques for ensuring a safe and compliant installation. It's also worth noting that some jurisdictions may have specific requirements or restrictions regarding drilling holes in outlet boxes. Check with your local electrical inspector or building department to determine if there are any additional regulations that apply to your project. Remember, the primary goal is to ensure that the outlet box is securely fastened, adequately supported, and maintains its electrical integrity after the modification. By following these guidelines and taking the necessary precautions, you can safely and effectively drill holes in outlet boxes to provide alternative mounting locations while complying with the NEC and ensuring electrical safety. Now, let's further elaborate on the practical aspects of drilling outlet boxes, providing more detailed guidance on tool selection, hole placement, and fastener selection. Firstly, when selecting drill bits for drilling outlet boxes, consider the material of the box and the size of the hole you need to create. For metal boxes, use high-speed steel or HSS drill bits or step drill bits. HSS bits are durable and can effectively cut through steel or aluminum. Step drill bits are ideal for creating clean, round holes of varying sizes without the need to change bits. For plastic boxes, use drill bits specifically designed for plastic, or use a step drill bit. These bits have a sharper cutting edge that minimizes the risk of cracking or chipping the plastic. Secondly, before drilling any holes, carefully measure and mark the desired location of the holes on the outlet box. Use a pencil or marker to create clear and accurate markings. Double-check your measurements to ensure that the holes will be properly aligned with the mounting surface and the equipment that will be attached to the box. Thirdly, when drilling the holes, use a drill press or a handheld drill with a steady hand. Apply consistent pressure and avoid forcing the drill bit, which can damage the box or create jagged edges. If using a handheld drill, use the center punch to create a starting point for the drill bit, which will prevent it from wandering. Fourthly, after drilling the holes, use a deburring tool or file to remove any burrs or sharp edges. Burrs and sharp edges can damage conductors or create a safety hazard. Smooth the edges of the holes to ensure a clean and safe surface. Fifthly, when selecting fasteners for mounting outlet boxes, consider the material of the box and the mounting surface. For metal boxes, use machine screws or bolts with lock washers to prevent loosening. For plastic boxes, use self-tapping screws or bolts with washers. Ensure that the fasteners are long enough to provide a secure hold, but not so long that they protrude excessively. Sixthly, when fastening the outlet box, use a torque wrench to tighten the fasteners to the proper torque specification. Over-tightening can damage the box or the mounting surface, while under-tightening can result in a loose and unstable connection. Refer to the manufacturer's instructions or a torque chart for the recommended torque values. Seventhly, after mounting the outlet box, inspect it carefully to ensure that it is securely fastened and adequately supported. Check for any signs of movement or instability. If necessary, add additional support or reinforcement to ensure that the box remains firmly in place. It's also important to consider the specific requirements of the NEC and any local electrical codes that may apply to your installation. These codes may provide additional guidance on the proper methods for mounting outlet boxes and ensuring electrical safety. When in doubt, consult with a qualified electrician to ensure that your installation complies with all applicable codes and standards. Furthermore, always prioritize safety when working with electrical components. To energize the circuit before drilling any holes in outlet boxes. Wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves to protect yourself from injury. Work in a well-lit and ventilated area. By following these detailed guidelines and taking the necessary precautions, you can safely and effectively drill holes in outlet boxes to provide alternative mounting locations while maintaining compliance with the NEC and ensuring electrical safety. Let's examine the significance of grounding and bonding when modifying outlet boxes alongside additional safety considerations. Firstly, grounding and bonding are crucial for electrical safety. NEC Article 250 outlines the requirements for grounding and bonding electrical systems to minimize the risk of electric shock and fire hazards. When drilling holes in metal outlet boxes, it is essential to maintain the continuity of the grounding path. Secondly, ensure that the metal outlet box is properly grounded by connecting it to the grounding electrode conductor or equipment grounding conductor. This connection provides a low impedance path for fault current to return to the source, tripping the circuit breaker or fuse and to energizing the circuit. Thirdly, when drilling holes in metal outlet boxes, avoid damaging the grounding connections or creating gaps in the grounding path. If necessary, use grounding bushings or bonding jumpers to maintain continuity around the drilled holes. Fourthly, for non-metallic outlet boxes, grounding is typically achieved through the equipment grounding conductor that runs with the circuit conductors. Ensure that the equipment grounding conductor is properly connected to the grounding terminal inside the box and to the equipment or device being supplied. Fifthly, when modifying outlet boxes, be aware of the potential for creating galvanic corrosion. Galvanic corrosion occurs when dissimilar metals come into contact in the presence of an electrolyte, such as moisture. This can lead to the deterioration of the metal and a loss of grounding continuity. Sixthly, to prevent galvanic corrosion, use compatible materials for the outlet box, fasteners, and grounding connections. If dissimilar metals must be used, apply a corrosion inhibitor or dielectric coating to prevent direct contact between the metals. Seventhly, when working with electrical systems, always follow safe work practices. To energize the circuit before drilling any holes in outlet boxes. Use insulated tools to prevent accidental contact with energized conductors. Wear appropriate personal protective equipment such as safety glasses and gloves to protect yourself from injury. Furthermore, consider the impact of drilling holes on the structural integrity of the outlet box. Excessive drilling can weaken the box or reduce its ability to withstand mechanical stress. Avoid drilling too many holes or holes that are too large. If necessary, reinforce the box with additional supports or brackets. Also, be mindful of the potential for creating electromagnetic interference, or EMI, when drilling holes in metal outlet boxes. EMI can disrupt the operation of sensitive electronic equipment. To minimize EMI, use shielded outlet boxes and grounding techniques. In addition to the above considerations, remember to properly label the modified outlet box to indicate that it has been altered. This will alert future electricians or technicians to the changes that have been made. When in doubt, Always consult with a qualified electrician to ensure that your modifications comply with all applicable codes and standards and that the electrical system remains safe and reliable. By adhering to these grounding, bonding, and safety guidelines, you can confidently drill outlet boxes while upholding electrical safety standards.